Implementing stack by making use of list. Stack means elements are arranged one above the other. So we are going to arrange elements one above the other by making use of a list. You consider a list with 9 elements. In forward indexing, the indices are: for the first element the index is 0, for the next element the index is 1, and so on. Suppose variable s points to this list. I want to insert the first element 10 into the list. As you know, now the list is empty and I am going to insert the first element 10 into list. So when I make use of s dot append within bracket 10, the element 10 is appended to the list, that is, it is inserted into the list. So the element 10 is inserted or appended into the list. Now this is the topmost element as well as the element at the bottom, because there is only one element in the list. Again, let me insert one more element into stack using list. So s dot append within bracket 20. So 20 is appended to the list, that is 20 is inserted here, which means we can say that 20 is inserted at the top. So now this is bottom of the stack, this is top of the stack. Let me insert one more element 30. The statement is s dot append within bracket 30. So 30 is appended to the stack, that is, it is inserted at the top. So now this is bottom of the stack, this is top of the stack. Finally, let me insert one more element. So the code is s dot append within bracket 40. So 40 is appended to the stack, it is inserted at the top. So in order to insert element into stack implemented using list, the statement is s dot append within bracket the element that you want to insert. Let me write the code for push function. Push means inserting element into stack. Start with the keyword def followed by name of the function, function symbol followed by colon. The stack should be passed to this function and the element that you want to insert, that should be passed. This element is read in the main function, so that when you call this function it should be passed. Similarly, s points to an empty list. When you call this function, that list must be passed. You need to write the document string, and in order to insert the element, the statement is s dot append within bracket the element that you want to insert. So using this function, you can insert an element into stack implemented using list. Now you consider a stack with 4 elements, stack implemented using list. The topmost element is the first one to be deleted. So if you want to remove the topmost element, the code is s dot pop, because by default pop removes the topmost element from the stack. So this 40 is removed from stack using list, and that is returned as answer, so that this variable e contains the removed element 40. Now this is bottom of the stack, this is top of the stack. So if you want to remove the next topmost element, the same statement e is equal to s dot pop. So s dot pop, it removes the topmost element from stack maintained using list, that is returned as answer, so that this variable e contains 30. Now in order to write the code for deletion, start with the keyword def followed by name of the function, function symbol, and followed by colon. Certainly the list must be passed. You don't need to pass the element that you want to delete, because if it is stack, it is internationally accepted rule. The topmost element must be deleted first. Certainly you need to write the document string. If stack equal to empty, so if the list is empty, you can say that deletion leads to underflow. What is the meaning of underflow? From an empty data structure, from an empty stack, from an empty list, if you try to delete an element, the situation is known as underflow. Similarly, to a completely filled data structure or to a completely filled stack, if you try to insert an element, the situation is known as overflow. Anyway, here we are bothered about underflow. So if the list is empty, deletion leads to underflow. Otherwise, you can delete an element from stack implemented using list. So you need to call the function s.pop. This deletes the topmost element from the list, that is returned as answer stored in variable e, and you can display element deleted equal to e. Now let me define the function peek. What's the meaning of peek? The peek function returns the topmost element of stack implemented using list. Remember, the peek function does not delete the topmost element, it simply returns the topmost element. In order to write a function, use the keyword def followed by name of the function, function symbol and colon. Certainly the list must be passed. You can write the document string. Then if the list is empty, s equal to empty, you can display the message empty. Here no need to write underflow, because what is the meaning of underflow? From an empty stack, from an empty list, if you try to delete an element, the situation is known as underflow. Here we are not deleting the element, we are simply displaying the topmost element, so you can simply write empty. Otherwise, you can display the topmost element. So s of -1 will give you the topmost element of a stack that can be stored in variable e, and e must be displayed in the computer's monitor. How does s of -1 returns the topmost element? You consider a list with 4 elements. This is forward indexing and this is backward indexing. So this is the element at the bottom, this is the topmost element. So if you want to return the topmost element, s of -1 will always give you the topmost element. Finally, I need to create a function that will display all the elements of stack implemented using list. You can create the function like this. Use the keyword def followed by suitable name for the function, function symbol and colon. Certainly the list must be passed. You should write a document string. If the list is empty, you can simply display the message empty. Otherwise, you can display each and every element of this list. So for I in S will give you each and every element of this list, and that must be displayed. But for I in S means the topmost element will not be displayed first. See, suppose this is the list. For I in S means here you will get each and every element of this list. The first element returned is 10. So variable I contains 10, and here 10 displayed in the computer's monitor. After that 20 is returned from the list. Variable I contains 20. So 20 displayed. Similarly 30 and 40. So you can see that the topmost element is not displayed first. So if you want the topmost element to be displayed first, reverse this list. And how do you reverse the list? You can use the keyword reversed within bracket S. So reversed of S will return the topmost element first. So here 40 returned, variable I contains 40, 40 displayed. Similarly, the next one returned 30. So here 30 returned, variable I contains 30, 30 displayed in the computer's monitor. Similarly 20 and 10. So now the topmost element is the first one to be displayed. Below that the next topmost, and so on. So in order to display each and every element of stack implemented using list, the code is for I in reversed S print I. So almost all the important functions are explained. The first one, push, used to insert an element into stack implemented using list. The next one is pop, to delete the topmost element from stack. The third one, peek, that does not delete the topmost element, it returns the topmost element. And finally the show function, which displays each and every element of stack starting from the topmost element and ending at element at the bottom.